I'm Alan Grosvenor, CEO of MisBay and CEO of our sister company, Temp-Fortis Solutions. And this is Simulations, the podcast. I'm here with Chris Dawson, one of our key team members in Temp-Fortis. And Chris, what a crazy year 2025 was. We were brought together by Prince Stash, who we've both met through Metal.
Yep, that's true. Yep. Yeah, it's kind of crazy that is the common connection.
And you started talking with Stash a year ago or more? 2 years ago?
Yeah, I think it's close to 2 or 3 years ago.
2 or 3 years ago, about your hobbyist work, inspired originally by your time in the Navy.
Yeah, so I started in the Navy as a nuclear chemist, and toward the end of that career, I was exposed to a lot of reactors in the shipyard. So it's like, oh, there's multiple sizes and different pieces to this. It's like, how small could we go? So then I really started thinking about the miniaturization of that, and it was fundamentally limited by the power generation side, basically turning steam into electrons. But then I went even smaller and started harvesting americium-241 sources. And say, okay, how small can I get?
Out of a smoke detector.
Out of a smoke detector. Yeah. So I was running around to secondhand stores and Habitat for Humanity and getting these old smoke detectors and pulling the sources out and then setting those up to create board level power. Just 2 volts, just to be able to prove that I could take something like that, produce power, and then, okay, now let's try to potentially scale up to then be able to do that. And then we fast forward, then I meet Stash, and he's trying to solve energy problems with his castle. And I was like, well, you got this and this and this. And he's like, well, what do you think about nuclear power? It's like, strange question, but I think a lot about nuclear power. I started going down that, and it's like, this is what I believe to be technically feasible with what's available today. So like, could your castle be a nuclear, have a nuclear reactor in the basement? Absolutely it could. And that put this earwig in his ear. And then he went off on a quest to go solve the problems that I said that can't happen because this, power generation. And then he comes up with the supercritical CO2 bit. And then I think that's where you intersected.
That's right. So just like you originally had this conversation, I think, in a breakout room at Metal.
Yeah.
So too did I in spring of 2025. We happened to be talking together. Stash was there and Nolan Bushnell was there, and we were talking about nuclear reactors, and Stash started talking about supercritical carbon dioxide, and I started mentioning that I thought his idea was good, and I happen to have some experience with high pressure carbon dioxide like operating turbo machinery from a company I used to work at called Ramgen. And he goes, every time I bring this up, nobody knows what the hell I'm talking about. You're the first person I've talked to that actually understands everything I've just said.
Yeah.
So then we started talking at his place in Malibu, and after a few weeks of talking, we decided that we better start something, and then we reached back out to you, and wow, here we are. And we have so many other team members that are incredible too. We got Mark Miller who was just retiring from Nuclear Regulatory Commission.
That's true,
Could not have been more perfect timing as well.
Right. Yeah, well, actually, when I got the text, I'm literally sitting in the shop with my little prototypes, my americium-241 prototypes sitting on the desk. And they're like, are you even interested in maybe pursuing that? And I'm like, hell yes.
Apparently, yeah.
Yeah, I was like, seriously, why haven't you called sooner?
That's awesome. That's exciting. And, many reasons why I was interested in doing this, but one of them was at my other company, MisBay, we've been using artificial intelligence to speed up the utilization of design and modeling and simulation tools to enable innovation.
Right.
And there are so many unique, creative, super innovative technologies that ought to already exist, like this.
Yeah.
That you can really speed up, and if you're able to use a lot of compute power, like the supercomputer time that we're very fortunate to have, then you can really evolve some unique new designs. And we came up with this reactor, and we designed it to be portable. So portable, you can put it on a helicopter and fly it in somewhere. And that ends up solving a huge amount of unmet needs that we didn't even know about.
Yeah, so there's a huge need. And then on the simulation side, when people think CFD, they think aerodynamics, fluid dynamics over an object, but it also allows us to go inside the system and really optimize the supercritical CO2. So it's an amazing tool that can be leveraged to that, which we will deploy in the development of this product.
Exactly, because it's like a jet engine,
Yeah.
but instead of squirting fuel in a combustor and lighting it and driving it through a turbine to either propel out of a nozzle or turn a generator, here we're turning our own generator, operating on working fluid supercritical carbon dioxide, which, unlike helium or steam, huge, massively spaced out molecules that need a huge volume.
Oh yeah.
We have the opportunity to pack this into a really tiny volume, and yeah, there's all this thermal balance of there's the radiator, then there's how are you going to pipe out that heat and then transmit it through a heat exchanger to the engine side, the supercritical carbon dioxide turbine machinery side.
Right. Yeah, and what a lot of people don't realize about like water, which is most nuclear reactors these days, is that as steam, it takes up 1,600 times the space as steam as it does as water. And so now you start to think about how much bigger do I have to make this equipment? So of course it was supercritical CO2. When you presented that to me, I felt so dumb for not having thought of that. I was like, of course, why didn't I think about the working fluid that is making this impossible?
And I'm really excited also about the opportunity with artificial intelligence that we have because, okay, you're designing a totally portable microreactor. We have end user customers that are saying, we want to use this in a forward operating base. We want to use this in a disaster zone or hazardous cleanup zone, remote mining operation. And so this thing better be fault tolerant, and it better be checking its own operations and be able to do a safe shutdown, or be able to handle any kind of things that'll come its way without requiring humans on site to have to train up on nuclear energy operations too much.
Yeah, and it also allows for efficient operation where the AI on board will know what's coming next. So it knows it needs to ramp up power, decelerate power, exhaust off, waste heat, and it's going to be able to manage that whole system. So it's going to be a smart system, but it's going to be a dumb system for the interface.
Yeah.
So they just plug and play. It does all the thinking for them, and just you drop it wherever you need power, plug in, ready to go. And then when we look at the application, this is the perfect form factor to solve a lot of these things that you listed. A lot of other microreactor development is in the megawatt range, and there's need for that. But we have a lot more need on the fringes, on the edge, like a forward operating base. They don't need a megawatt of power. They need 30 to 40 kilowatts continuous to power communications, weapons, maintain a certain livability. And this opens that up. Because to date, they have to ship JP8 to go run a JP8 generator, and it costs around $500 to $600 per gallon to get it out there. Because there's not a pipeline, there's not an infrastructure that's already set. We're using the highest grade, most expensive military equipment to shuttle liquid power out to the battlefield.
Constantly.
Right, and so this allows us
and
to
you're
drop
generating a huge amount of heat and noise out there doing it.
Right, exactly. They know immediately that you are there. This can be
particularly autonomous drones do.
Right. So this can be dropped in the dead of night. No one would even know that it's there, and you have enough to stand up a camp overnight with this power. And if you need more power, you just add one. Yeah. So not only is it really the right size for most applications, when you need more power, it's now microreactor Legos. We rack and stack our way to a solution.
And there's a couple different intervals where I knew we got something here, because everybody we talk to is excited about it and wants to help us and wants to work with us. The Department of Energy National Labs, we got several working with us. Yeah. We got a outfit out of the Navy that's helping us with resources. And then we're very extraordinarily lucky to be working with Molly Johnner, who's helping us get the word out, connect with customers, and find the right opportunities, and also liaise with some investors that have been really important. But also her colleague, Major General Chris Hughes.
Oh yeah.
When he came on our team, wow, things started moving. And
he's the real deal.
Oh my God. And he got it right away. Like, he has lived the reason why they need this in forward operating bases himself. So he got it right away. And wow, when he sent our one pager to the Pentagon, they responded immediately. And
Yep.
we got a meeting with the Secretary of the Army
Yeah.
coming up. He told us that it's unprecedented to just get invited to the Pentagon like that.
Yeah. I mean, having done a few other military contracts, that's never happened.
Yeah.
And it never happens in that direction either. Generally, you beg and plead, and hopefully you make it through all the gates, and then you get that meeting.
Gosh, and you've had a lot of, you've had like so much travel lately.
Yeah.
You were in Japan, now you're heading out to,
Dubai.
yeah,
Yeah, so I got a big conference out there. I'm delivering a keynote on electrifying the future
awesome.
and what that looks like. And really what that talk will be about is how electrification or battery storage complements all these other energy bits. I think we now are starting to see where battery storage kind of falls down, the environmental impacts of the mining, as well as the weight, the cost to build it. We're realizing that smaller battery applications marry very well with things like nuclear, things like hydrogen, or any other power source, and using it in a small amount to manage transients. And that allows you for smoother, more efficient operation on the generations. And so naturally driving electrification is driving all the other energy bits with it. Because what we really need to do around energy is what is the right tool for the job. Historically, I don't think that intellectual vigor has been applied to battery storage. They're like, oh, electric vehicles are going to solve everything. Well, they're really good at a lot of things, and they're really bad at a lot of things as well.
Yeah.
And so now I think everyone's coming down to this rational things like the nuclear is the right tool for a lot of things. Batteries is as well. Hydrogen is as well. And I think when we look at the whole tool set and is applying what makes the most sense, and what microreactors forward deployed at a forward operating base now do is allow us to take the most cutting edge electric and hydrogen technology, deploy it out,
Yeah.
power it with this at a baseline, and now our soldiers have the best, most technologically advanced equipment,
Yeah.
which means more of them come home, which means we start to automate that process, and less of them are even there to begin with. And so micronuclear is how we get there.
100%. And, when we're talking about nuclear, we're not talking about 3 Mile Island or Chernobyl or Fukushima.
Nope.
We're not talking about like 1960s style reactors. We're talking about the latest nuclear fuel configurations that for the first time are inherently safe, like meltdown proof in a way that's really never been true until about the last 5 years. They started really proving it, and that's changed everything.
Yeah, 100%. The name of the game is, can I keep the dragon in the can? Because when it comes out of the can, bad things happen. And that's what we see, Chernobyl and 3 Mile Island, Fukushima. Those are all old technology. A lot of those technologies are 50s, 60s, and 70s technology in nuclear.
Yeah.
And one, it takes so long to build a nuclear reactor. Also, in order to get it quasi-economical, you have to use these large amounts of fuel in order to kind of hit those targets. And these are predominantly driven by investors, so they need to see an ROI like in a few years, not 10, 20, 30 years. And so for all these reasons, actually, here's a perfect example of
Good timing.
Yeah, good timing. You can see how small those little pellets are. And predominantly they're encased in a ceramic. That ceramic has high temperature tolerance. So even if we had a quote unquote runaway reaction in a small little pellet, it is not likely that it's going to even be able to escape that coating.
It's striking this balance where you're getting enough reactivity
Yep.
to trigger the fission reaction you need to generate enough heat. And we're talking about like 700 Celsius kind of heat.
Right.
But you try to melt that down, like you turn off all the cooling, it will not melt down.
Yeah, so it won't melt down, which means it stays inside the can.
Yeah.
So worst case scenario, you have a really hot rock for a while, but it's not irradiating the environment around.
Exactly. Which has changed everything and
Yeah.
really made this thing possible.
Yeah, absolutely.
Because, if you're doing it the old way, you're not going to try to ultimately put this eventually in a home. You're never going to do that.
Right.
In fact, the government's never going to allow you to try to do that.
Right.
Because that's like an obvious like dirty bomb. Weaponizing this is a lot harder.
Oh yeah, incredibly. It's like one, we won't have to reach the levels of enrichment to get to weapons grade, which means we'll be able to be in that 15 to 25% enrichment, which is already in the process. And what we need to do this is scraps comparatively what everybody else needs to do. So we'll always have enough fuel available because we can reach in the couch cushions and pick up a couple pellets and then build a reactor based on that.
Totally, which, you know, there's so many dimensions of this that's exciting, and like coming together in a way that enables this brand new solution that really has not been feasible before. We got a fuel configuration that is inherently safe in a manner that makes true portable nuclear, like helicopter portable nuclear, a feasible value proposition and something that you can use forward operating bases, emergency response, hazardous waste operations, remote mining operations, but also hospital power, backup power, hotel and resort backup power. Lots of people watching have experienced some, you know, hurricane or somewhere where the power went out for a long duration of time, and they waited forever until they found a way to turn the lights back on. Well, you know, switch this baby on, and you're there. And like it, I was talking about before, our team member Mark, who was at Nuclear Regulatory Commission. He's been cluing us into what's been happening in the regulatory environment lately, and some of the latest regs that apply to the smallest classes of microreactors that appear to make it possible by 2029, 2030 to be able to actually make this a true consumer electronics product. Like we're here at the Consumer Electronics Show, and yet I don't think there's any other nuclear reactor that's ever been showcased at the Consumer Electronics Show. I would like to say that we're the first, and I didn't even imagine when we were starting this proposition that was going to be a possible outcome. But it looks like, hopefully, there will be a day where somebody at the show could do a Amazon Prime one-click purchase for our microreactor.
Yeah, I mean, that's the world I see, and that's what we're trying to build.
Yeah, and there's so much that we can do just for the warfighter, and that's what we're focused on right now. But it so happens that the same unit that we're designing for them and evolving and proving out will have so many super positive consumer end user business use cases.
Yeah, and this is only one step of production.
Yeah.
Like we can continue to miniaturize the technology.
Right, and we should talk about the fact that we have our palm size mini cell. We should talk about that a little bit.
Yeah, so also with this, we're doing this palm size thing, a little bit bigger than an iPhone. And what that will do is allow you to carry around watt level power, power devices, your laptop, your basics in and around. And we see that's the first kind of stage.
Recharge your phone.
And first stage of miniaturization. But it is likely then we continue to drive that down where these systems start to be already integrated into your phone, into your laptop.
Right.
There's been some interest.
And like, it's not that much radiation, and we have like really effective ways to really effectively shield it. And we're starting to work with some exotic materials in the shielding that give us some mass and volume advantages.
Yeah, and thermal conductivity as well, being able to pull that out, run it through thermoelectric generators. And so we have a nice static, even keel output, and then you use that for your various device needs. And then with some of the AI development around material choices, being able to do now gradient materials at a high level, so to work on thermal conductivity as well as shielding, as well as selecting very specific fuel types for this kind of application. It's not going to be uranium-234. It's going to be these smaller bits that have less particles that we have to deal with, so therefore we can reduce the overall shielding requirements, and so we can pick fairly inert particle-emitting fuel sources that allows us to shield it with very little material, but still generate enough heat to have usable power.
It's awesome. There's so much that's come together so quickly, and we've got a lot of interest in this show already.
Yeah. Just standing here, just hitting one after another. Everyone wants to know, like, what is it? Is this really possible? I can't believe I'm looking at it.
Yeah, and then here's why I want it.
Yeah. And so far, I haven't had anybody tell me it's a horrible idea.
Right. That's also a good sign.
Yeah, I've been waiting for someone who's just like anti-nuclear to come in and read me the riot act.
Well, see, that's the thing. I mean, it used to be pretty easy to be anti-nuclear because you got like a Rube Goldberg machine.
Yeah.
That's like a ticking time bomb. Like, I mean, you know, this way is so much better.
Yeah, absolutely. So like there's beauty in the simplification of the process,
Yeah.
but as well as utilizing the more recent technology. Like we're decades removed from where we really should have been had we continued to develop. But like I said, because of these machines, these power plants are so complicated, it's taking 10, 20 years to build these in a safe manner. And by the time you break ground, the technology has advanced. But you can't retroactively go back and make these changes because of one, all the regulatory requirements, the safety required. You have to just bulldoze through. And so there's no reactor really. I mean, I think they just launched the one in Georgia. But even that, the technology that drives that is still decades old. And so this allows us to move very quickly, put the best technology forward, and it starts to compartmentalize the energy structure, whether it's forward operating base, a full-blown military base, or a community. You now have this decentralized power system that we don't need to spend trillions of dollars upgrading the national grid to be able to support. Like if we did all these large nuclear plants, yeah, now we're producing the power, but I still got to get the electrons out there to the edge.
Right.
This allows us to drop it at the edge and now build an insanely robust infrastructure that is nigh indestructible because now power can be rerouted from tens of thousands, if not millions of power generation points.
And there's one more dimension that I wanted to talk about for a second. But I mean, just to recap so far, we got portable nuclear power to meet remote use case, unmet needs. We got a fuel configuration that makes it possible, that enables us to have an inherently safe configuration. It's not going to melt down. And there's this renaissance in nuclear energy that's been happening since the spring in the United States.
Yeah.
4 executive orders that really sparked off what was already happening, but just really took it to the next level. And as a consequence of this fuel configuration and all the new business cases that have become emerging, there's a new economies of scale, legitimate, real, practical recycling option now for this fuel, which really was not like true decades ago. Like it used to be, okay, you're gonna spend your fuel, then you're gonna put it encased in some exotic material and bury it in bedrock for 40,000 years. Whereas now it's like, okay, no, but 5-10 years of use of this unit. If you're leasing it from us, we're gonna take it back, take it to the recycling.
Right. Yeah, insert a new core and then you're off to the races for another 5+ years.
Yeah.
And then we can then rework that, reconstitute it, re-encapsulate it, and now it's new fuel that's as good as the other new fuel. And then the constituent parts we're able to work through recycling process to pull off, send back into industry for various use cases in battery and superconductors and all those other pieces. So it's this full like recycle opportunity that has never existed because of the current technology that exists today, both in the fuel as well as post-processing opportunities.
It's such a super exciting time. And Chris, I'm so thrilled to be working together with you and Stash
likewise.
and the other people on our team. You know, that's another thing that's magical about what's happened is the people that started emerging and on the team also are partners. It's incredible.
Yeah, and this is before any executive orders.
Right.
So when you called me, I was like, okay, this is going to be the Sisyphus moment. It's like, we're all signing up to push this boulder uphill. At least I won't be doing it by myself.
Yeah, right.
And we all pile in. And it's like 2 months later, executive order, executive order, executive order. And then that slope started to feel downhill. Now I feel like it's pulling us
You know what?
in a direction.
It was actually 1 month.
Yeah, I know.
It's crazy, right?
Yeah, that is nuts.
We created the company in April. It was May 23rd.
Yeah.
Those executive orders came out.
Yeah, and so it's just like, clearly the universe stepped in, pushed us all together.
Yeah.
And everybody said yes, right? There's no no's across it. And like, this is not an easy problem. And then all of a sudden, like, it's like slope shifted and now everyone's running to keep up.
So I mean, with Stash's vision and the way he really spent time thinking through what you and he started talking about like a couple years ago, a few years ago, and then with your experience starting with the Navy and also some of the incredible experience that you had with Tesla. These are all really essential things that you need to have real experience in. Like, you can come up with a theory, but if you actually have practical experience like you do from the Navy, and also practical industrial experience that you have from Tesla, for example.
Yeah, I think being able to understand what those electrons are then used for helps you model how to generate them.
Yeah.
And so generally you don't see that in the nuclear field. There's like, how much power can I make in such a small space? But now, having run a few businesses, been early days Tesla, done a bunch of other startups in the battery space, charging space, hybrid vehicles, full electric vehicles, autonomous vehicles, understanding is like, hang on, like, we have to focus on a customer. What does the customer need? And that's what we should generate.
Absolutely.
That's what this reflects.
Incredible. Well, Chris, it's been a pleasure talking with you about this. I can't wait to see what comes next. And our trip to DC is going to be magical, I think.
Yeah, magically intense, I'm sure.
Cheers.
All
man.
right. Thank you.